Hey guys, this video is going to focus on finding the labeled values when given what looks to be trapezoids. So we're given the following two shapes here. So example A and example B are very similar to each other. Now anytime you're given a geometry problem based off the figure, it's really good to first know what is that shape. Are there any particular rules or formulas that pertain to that shape? Also pay really close attention to what are they asking you to find out, because we need to pay attention to that in order to figure out, are there any values that are missing that we need to know? How do we figure out what those missing values are in order to solve the problem? So what they're asking us to find is they want us to find EF, so this line right over here, and they want us to find the side AD. So those are the sides that have X's for their values here. So there's going to be a little bit of solving that we need to figure out. So we need to find those two lines right here. We're not giving any angles, we're not giving any other sides or anything like that. The only other information that I see is, if you notice these tick marks that I have over here, right? So these tick marks on the left hand side, so that means that this side here, this BE, is equal to EA. So these are the same length. Over here on the right hand side, the same thing as well. DF is equal to FC because they have them labeled that they are exactly the same. So if those two are exactly the same, I see that this line EF, which is one of the lines that they want us to find, connects these two sides together. So where it connects here, it happens to split these two in half, just like where it connects here, it splits these two perfectly in half. And when that happens, that's actually called a midsegment for this particular shape here. So a midsegment kind of just splits those two sides perfectly evenly. Now, the fact that we know that this is a midsegment, along with the fact that this is a trapezoidal type shape, this is the information that we need to know in order to solve this problem. So the midsegment is known to be half of the two bases. So this line right over here that we're trying to find is half of the bases of this trapezoid. Now the bases of this trapezoid are the AD and the BC, those two lines right over here. So 6x is half of both of those together. Now, we got to be careful here in setting up the equation that we have to solve. So again, the midsegment is half of the two bases combined. So what we're going to do, we're going to create an equation. On the left side of your equation is going to be your midsegment value. Our midsegment, the EF, is equal to 6x. So that's going to be the left side of my equation. 6x is equal to. Now it's equal to half of the bases. So do your equals, put in your half. It's equal to half of the two bases. So we're going to need to multiply that by the two bases. But it's half of both of those bases. So what we need to do is we need to combine the two bases together, because it's half of the x plus 9 and the 90 together. So if I were to draw out these lines side by side, right, this plus this, the 6x is half of both of those together. So it's half of the x plus 9 plus the 90. Okay, so your equation on the left hand side is your midsegment, is equal to 1/2, and in parentheses put your top base plus your bottom base together. So the x plus 9 plus the 90. And this is the equation that we need to solve. So we need to do some cleanup for this equation first. Inside these parentheses we have some like terms that need to be combined. So drop down the 6x is equal to the 1/2. We need to go ahead and add the 9 plus 90 together. So drop down the x. 9 plus 90 is equal to 99. So we need to solve this equation here. So to make this a little bit easier, what I'm going to do is I'm going to get rid of this fraction. Remember that you can get rid of a fraction by multiplying by its reciprocal. So this fraction is 1/2. If I flip that fraction around, it's a 2/1. I'm going to multiply both sides by 2 just so I can get rid of this fraction and not have to deal with it. 1/2 times 2, half of 2 is just a 1. So those actually go away. That way I can just drop down directly what's inside my parentheses to make that a lot easier. And on the left-hand side, 2 times 6x, well, 2 times 6 is 12, drop down the x with it. So you can see I got rid of the fractions to make it a lot easier to solve here. Otherwise, I'm solving for x, so let's get our x values together on the same side. Remember that this is a 1x, a positive 1x, so we are going to subtract that x over to the other side, which is going to leave us with 99 on the right-hand side. On the left side, 12x minus 1x is now an 11x. And all we have to do is divide out the coefficient, and we're left that x is equal to 9. I'm sorry. 99 divided by 11 is 9. So we are given that x is equal to 9. Now, going back to what this problem asked us to do, it did not ask us to find x. It wants us to find EF, and it wants us to find AD. So EF is right over here. Now EF is equal to 6x, right? So if EF is equal to 6x, but we now know what x is. We know that x is equal to 9. So we're going to do a quick substitution here and just plug in 9 for x, and 6 times 9 is equal to 54. So that is how long EF is. So we're going to do the same thing for AD then. So AD is x plus 9, but we know that x is equal to 9, so we can plug in the 9 for x, which gives us 9 plus 9, which is 18. So that means the side AD is equal to 18. Okay, so it's very, very important that you get the equation set up correctly and you solve that, because you can see we then take that value and substitute it into our sides in order to find their full length here. So we're going to do that same exact thing, but with example B over here. So I'm going to erase this, and we're going to set up our new equation with example B using the same exact rule, keeping in mind that our midsegment is 1/2 of the two bases combined. So when we take a look at example B, we have the same situation going here. We have EF, which is one of the sides we need to find. We also need to find AD, and we also need to find BC for here. But we can see EF, which is our midsegment. It does cut this left side perfectly in half. It also cuts this right side perfectly in half. So we do know that it is a midsegment, which means that we can use the midsegment rule that says that that midsegment is 1/2 the combined bases. So again, on the left side of your equation is your midsegment, which for our example here is going to be an x. That is going to equal to 1/2 times, and add your two bases together. The first base is x minus 9, and add that, so go ahead and just say plus, your second base, which is 2x minus 6. All right, so midsegment is equal to 1/2 times your two bases. Let's do some cleanup inside the parentheses. We do have some like terms that need to be combined. X and 2x can be combined. -9 and -6 can be combined. So let's drop down the x is equal to the 1/2. X plus 2x is 3x. -9 and -6 is a -15. So because we have our fraction right over here, now I could take that 1/2 and multiply it into my parentheses and use the distributive property, but because it's a fraction and it doesn't happen to be a nice pretty fraction with the numbers that we have here, I'm going to do the same thing, and I'm just going to multiply by the reciprocal for this example here. I'm going to multiply by the 2 again. Alright, so because we have the fraction of the 1/2, I'm going to use this reciprocal and multiply both sides of the equation by it just to get rid of the fraction and make it a little bit easier for us. right? So 1/2 you multiply by 2. Had that been 1/3, I'd multiply by 3, and so on like that. But otherwise, half of 2 is equal to 1. That goes away. Again, that's exactly why I use this rule, because it gets rid of the fraction. And on the left-hand side, we had an x. We're multiplying it by 2. So that is now 2x. I'm going to need to get my x values all together on one side. So I need to subtract that 3x to both sides, which cancels it on the right, leaving me with a negative 15 on the right. On the left-hand side, 2x minus 3x is actually a negative 1x. And we just need to get rid of this negative that's in front of that x. So we're going to divide out that negative, giving us that x is equal to 15. So again, that is not our answer. That is just the value of x. We now need to backtrack and go and figure out what is EF, what is AD, and what is BC. So let's start with EF. Now EF is equal to x, right? So we can actually say, well, EF is then 15 because x is equal to 15. EF is x, so we can plug in that 15 directly. The next thing they want us to find is AD. So AD is the top base over here. So AD is equal to x minus 9. We now know that x is 15, so we can plug in that 15 for x and simplify this. 15 minus 9 gives us a 6. So that means AD is equal to 6. And last substitution here, we need to find BC. Now BC is equal to 2x minus 6. Let's plug in the 15 for x and see what we get. Multiply before you subtract. 2 times 15 is 30. And 30 minus 6 is equal to a 24. So that means that BC is equal to 24. Otherwise, that is how we find our missing sides here for these particular figures. That is it for this video.